I don't know exactly how it works, but I remember messing around with that a while ago. So at its base, though, all of these data types I've just talked about and all the other data types are stored in the computer as binary. And the difference between, an integer, a character, a fraction, a floating point number, a word, is how that binary is interpreted. But it's all just a string of bits. So, yeah, RAM versus storage. So I mentioned. Oh wait, I'm actually in the wrong chat. I should be in the challenge room chat. 1 second. Okay. I mentioned that it's stored inside the computer. It's all these strings of bits are kept inside the computer in one of two places. The volatile memory, often called RAM, which is short for random access memory. It's volatile because as soon as you unplug your computer, it stops storing. Oh, okay. It stops storing all the data that was stored in RAM when your computer loses power. And then there's non-volatile memory, often just called storage, where these bits are stored for a longer period of time, just, in the computer. And that's so that you can keep your pictures, your programs, data, that kind of stuff, without having to redo it every time you turn on your computer. So the more important kind for our purposes is RAM, random access memory. It's a matrix, a 2x2 grid, effectively, of cells, each storing a small amount of information. Each piece of information has an address with a row and a column, and that's just a number, just the number row and the number column. And it can be written to or read from in any order. That's the important part. It's random access. You can say, I want this row and this column. What is in that spot? The other type of storage, data storage, are the hard drives and solid state drives. If we have extra time, I can maybe talk about how they work if you're interested, but they're less important for our purposes. This is where your program is stored when it's not being run, so that you don't have to, rewrite it. So I'm going to talk a little bit more in detail about how RAM works. So it's a matrix of small squares, you can think of them, and if you zoom out a little bit, it's all sequences of bits, but those bits are packaged into individual byte squares, which are then put in a large grid. So I'm going to abstract out the individual bits, and we're going to talk about bytes. So the address on this grid is just the row and the column. So that's stored in binary. So for example, this red square here would be 12,16, or that binary number you see there I don't feel like reading out. That being said, though, because I don't want to read that out, well, I'm not alone in that. You don't want to read out 16 bits or significantly more. RAM is not just a small grid. Most computers have several gigabytes of RAM. So the length of the address gets bigger the more RAM you have. So we use something called hexadecimal to make it a little bit more readable. Hexadecimal is base 16, whereas binary is base 2. So we can then group groups of 4 bits into one symbol. So then it would become 0C10. And that would be then the shorter address of the red square. So we can further simplify it, because thinking about it as a grid can be somewhat complicated. So it's often simplified into a table. So this table has just the address on one side and the data on the other side. The address is C10, and the data is that red square. And that's often how it's viewed, but it's helpful to sort of keep in the back of your mind that this isn't actually a table. It's actually a matrix. But just 1 byte, as we talked about before, is not very much. 1 byte is 1 letter, 1 number. It's called the byte width, how much is stored at 1 address point. And there are other byte widths, but we're just going to be talking about it. There's like other widths to the RAM, which you can think about as sort of the width of this table, how much data you can store in 1 entry. But that's not enough. Like, no matter how big your width is, it's never going to be as big to hold, you know, a whole program, a whole image, that kind of thing. So instead, it's split into byte parts and stored sequentially. So it's split up into individual letters and stored in a row. So that would look kind of like this. And now this is just one small part of the RAM. And there are other ways to store this data that I think you may be hearing a bit about next lesson. It's not always stored directly in a line, but that's sort of the simplest way to do it. But that's sort of all the general abstract part. What about the specific, when I'm actually sitting down to write a program? One of the most important parts of a program is the variable. I'll pass to you, Trevor.
So I'll be talking about those. Thanks for that, Kegan. I just want to say that I'm sorry because while I was managing the slideshow, I was also in the middle of class. So yeah, I just got out, so I can talk now. So I'm going to be talking about variables. So the first thing I'll talk about is how variables work at a lower level. So we all know that variables are like a label for a specific piece of data stored in memory, right? So for example, if we have 7 stored at address 0x1337, then a variable named x would refer to a byte that's stored at address 0x1337. And in this case, x is just another way to say 0x1337. All right, so what a literal is it's just a literal value in a program. So for example here, if we have x equals 127 and y equals hello world, 127 is a literal because it literally means 127. And same thing here for hello world. So you guys might be asking why we distinguish between these two values, x and 127, if in the end they both mean 127. And the reason why is because x is able to change its value. So in this case, we have x, which is equal to 10, and we have 10 here, which is a literal, so it's literally 10. And when we reassign x to the literal 11, then x now isn't 10. So x can't be literal. It's a variable. The next thing I'll be talking about is pointers and references. And this is more stuff about how variables interact with memory. So a pointer is still a variable, but what it does is it stores the memory address of another variable. So for example, if we had the variable x, which is set equal to 6 and is stored at the location 0x1337, and we have a pointer called y, which is a variable stored at 1338, but holds the value 0x1337, and that's just the address of x. So here we would call y a pointer to x. And something that's similar to a pointer is a reference. And what a reference is it's just a variable that acts like another label for a piece of data stored in memory. Another illustration here is x is equal to 8 at 1337, and y is equal to 8 at 1337 too. So x is a variable, but y is a reference to 1337. So they're like nicknames. All right, so I'll talk about an analogy for memory that makes pointers and references a bit more easy to understand. which is we can imagine memory as like a large neighborhood, where it's made up of houses that each have a unique address and contents. A pointer would be like a GPS that leads you to whichever address is plugged into the GPS. So go to the house at 0x1337. A reference is like a name for a building. So one building can have a bunch of different names, like where we can have SJAM, which has an address of 650 Laurelwood Drive. So we can, when we're referring to SJAM, we can call it Sir Johnny Macdonald Secondary School, or we could call it that one building at 650 Laurelwood Drive. And they're still in the end the same building, and they have the same contents inside. So if we're saying change the value at SGEM is the same thing as saying change the value at 650 Laurelwood Drive. So that's a reference. The next thing I think would be nice to go over is function parameters. And this is just the way that we pass arguments to functions. So those are just these guys here. So let's just say if we had a function func AB that takes two values, A and B, as input, we could either pass literals or variables as arguments. So if we had a function called sum, which takes two parameters x and y, we can call sum 1 and 2, and that would be passing literals. If we had two variables called a and b, we can call sum a and b, and that'd be passing variables. And there are two common methods of passing variables as arguments, which is passing by value and passing by reference. So I'm going to go more into detail about passing by reference here, which is basically you're giving the function a reference to the original variable. And doing this with pointers is just called passing by pointer. And the implications of passing the actual reference to the function is that it's like you give the function the address of the house that you're using as an argument. And in this case, the function will be able to modify the contents of the original house. And the next method is passing by value, which is slightly different from passing by reference, in which you actually pass the value to the function. And what happens here is that you create a new variable at a different memory location with the same value as the argument, and you give it to the function. So it's like constructing a new house. And the thing about this new house is that the function can't modify the values in the original house because the function never got the address to the original house. So the function only has this new house to work with. And passing by reference and passing by value both have their own advantages and disadvantages, which we'll go over in some examples probably. So I can switch my screen to REPL.it and go over a couple of examples. So we'll be back soon. All right. Let's see if I remember my REPL login. Okay, we're good. We are okay. Hi guys. All right, we're back. So this is C++. We don't need to worry about the syntax too much for now. I just want to illustrate some examples of how pointers would work and how references would work. Okay, let's do example one. Example one. Is everyone in? I think. Okay, let's go. So a pointer. Oops. Here we go. So the first thing I'm going to do is I'm going to make a variable Don't worry about the syntax. All you need to know is that there's a variable called x right now. I'm going to give it the value 4. And this is a pointer, int y, which points to x. So the variable here, y, holds a reference to, the location, the memory location, to where x is. So an operator in C, actually maybe reference would be better. Yeah, whatever. So an operator in C, which is this, the star again, what does is it turns a pointer into the variable stored at the memory location. We'll go way more into detail about this at in our C++ the next lesson next week, or is it the week after? But yeah, don't worry too much about the syntax. If you don't already know C++, it looks kind of scary, but we'll all be used to it by the end of the next 2 weeks. So let's say we set this equal to 10 now. And the cool thing is so by doing this, we reset the value of where x is to 10. So if we print out the value for x, then we should get 10 being printed instead of 4. Oh, this is not good. What happened? We had a hard time while you're disconnected. Choose my changes. All right, and now I click run. And we see that when we printed x, the program printed 10. But we set x equal to 4 here, and we never changed x. What we did was we changed the value of the location where the pointer y pointed. And since y was pointing to where x was, then the value of x was updated from 4 to 10. All right, that was example 1. And here we go. Maybe let's do another one in Python. It's all good? Okay, we're in Python now. So this is example 2, which is passing by reference. So a feature, or I guess a quirk of Python is that a list, so let's say we just have this list. Lists are always stored as references in your code. So A is actually a reference instead of a variable. Or I guess they're still variables, but yep. So if we did this, you guys probably have seen this before. We set another variable equal to A called B, and then we update B. So let's just change the first element to 100. And if we print A, you can see that the first value of A changed, even though we never updated A in the code. And what happened here is that we gave a reference to A to B. So B is actually a reference to A. And we set the first value of B to be 100. And since B is just another name for A, we actually set the first value of A to 100 here. And in a function, this would look like, say, what should we call it, guys? Let's call it F. Call it F, or function with list. It takes an argument list, a list. And let's see. We set a list be equal to 100, and we do all this again. So a is equal to 1, 2, 3. We call function with list of a. Then we print a. I'll put a semicolon. And same thing happened here. because when we pass a to this function, we pass a reference to a. So when we changed the parameter in the function, we changed a itself. And then I don't think passing by value actually happens in Python. So we have to go back to C with for that. But the difference is if we pass by value, then when this happens and we print a wouldn't change. Because if this was passed by value, then a list would not be the same as a.
Just a quick announcement that attendance is open, so feel free to go over to the announcement channel. Hopefully it works this time. We'll see.
Yep. And I think that's all we have to go over for today. So if you guys have any questions, feel free to ask them. Let's see. Const x equals 2. It wouldn't be a literal because x, if you did, I think it's because if you do like const x is equal to 3, then at that point x would be equal to 3, like in the definition of x. Because like 2 is literally 2, but in different programs x can mean anything. There's something in C++ called constant expressions. I didn't really study those, so I wouldn't know, but I think const x would be a constant expression. Oh yeah, so if you guys have any more questions about memory, feel free to ask them or unmute and just say them out loud. Oh yeah, attendance is open, by the way, like Kegan said. So I think once you guys get attendance sorted, you're free to go. The difference between pointer and reference. Yeah, I kind of zoomed over that, so I can go back. Let's see. Maybe I'll go back to the slideshow because I have illustrations there. Here you go. So pointers. Okay, they're really, really similar things, pointers and references. And what I'm describing here is actually the way that they're defined in C, I'm pretty sure. So essentially, a reference is like you give a variable another name. So, for example, if you had a friend named Robert, and Robert has short forms like Bob or Rob, right? But in the end, Rob and Bob are just another way to say Robert. So that's a nice way to think about what references are. They're just another way to call a memory location. And on the other hand, pointers are a separate variable entirely at a separate memory location. And what pointers do is that they hold the memory location of another variable. Just like pointing. Um, I think literals for pointers are like memory locations. So in the slideshow, that would be 0x1 through 37.
I'm not entirely sure how it works, but are there like I know there's a null pointer. Is that considered a literal because there's only one possible value and it doesn't change?
I think null pointer means like there's no such thing there. Like
Mhm.
it's like a placeholder for no pointer. I'm actually not sure if that would be count as a literal. It probably would. I think. Because like usually null evaluates to 0, right? I guess it's dependent on the language.
I just looked it up, and I'm pretty sure null pointer is a literal. It's similar to just saying 0 or false or whatever.
Yeah, that makes sense. So can a pointer be a literal? So pointers are variables, and yeah, like I said, the memory address is the literal that they hold.